Hello, everyone. I'm Santona. I'm a product manager at Upsolver, and today we're having a continuation of our brown bag with the CTO series with Yoni Eini. We're going to talk about sync streams and unsynced streams and the use cases. So over to you, Yoni.
Hey, thank you very much. Okay, so this is a continuation of the last session. So if you haven't watched or heard the last session, I recommend you do, just to give a bit of context about kind of like what the different timestamps you're going to be dealing with are, and what the let's say what the reasoning is behind all of these architectural decisions that we've made. So the example I gave before, that like if you have multiple inputs, if one of them is stuck, it means everything is stuck. Now, I might not necessarily care to synchronize between the inputs. Maybe it's just like, streams of events that are going in from here, going in from there. I just want it all into my lake. In that case, you probably wouldn't want to synchronize either the inputs or the job that reads from them. Another example is if I'm creating a materialized view, for example, so materialized views in Upsolver are used in order to, you can also create materialized views in order to query data and get aggregate results in real time. But you can also use them in order to join between two tables in a very efficient way. So kind of a very common use case you're going to have is that you have, let's say, a table of events and a table of user interactions. And for each event, you want to enrich it with information from the user interactions. So you'll build a materialized view on top of the user interactions feed or table. And then you'll join between the two. So you'll take the stream of events, the table that's accepting the stream of events for the events, and join into the user interactions materialized view. And that's going to work very efficiently. And if everything is synced, so if the materialized view is synced and the job is synced and everything in the graph is synced, then if the user interaction stream is delayed for whatever reason, it's going to wait. So the join is going to make sure that both sources are running in lockstep. Now, this is super useful in a lot of cases. So if I'm joining between kind of like events that have some kind of a temporal connection. Let's say I have an advertising impression, and then a user clicks on the ad. So the click will usually happen within a few seconds. Let's say at worst within an hour of the impression. And that link in time is very important, because I'm going to want to then, when I get the click or I get the impression, I'm going to want to join in order to find the other one. Now, if one of the streams was down for whatever reason, it can cause delays that are longer than the normal window. That might make me miss the attribution. So that's very important, to keep things in sync when there's a temporal connection between them. The flip side of that is that sometimes I'm going to have tables that, they update every now and then, but I don't really care. So for example, like I might have a table that contains a list of zip codes. And, this updates once in a blue moon, and I'm updating it manually. And I really don't care if when I update it, it's like a second later that all the sources are going to know about it, or they're going to know about it immediately. Like, I don't care about the synchronization between the two. I just want, I want this to update, and I want everyone to know about it. So in that case, if this zip code table, for example, is again running on a cluster that I shut off, it's not going to continue updating. Now, it's not getting any updates, right? Because I'm not writing any data into it. But the fact that it's not processing data, it could have gotten updates, which I don't know about. So if it was a sync materialized view and a sync job, then it'll wait for that table to be up to date, even though it's like some, completely static table that I don't care about. So that's kind of an example where I would necessarily want the materialized view not to be synchronized, because I don't care about when the join happens. I just want to be able to join, and I definitely don't want my ETL to stop working because something happened to this table. So I'm going to pause here for just a few moments. If there are any questions or comments or anything that was unclear.
That makes sense. It's on the user then to determine when to use an unsynced stream and when to use a synced stream, right?
Yeah. So the user decides, and the default again is the unsynced, in order to match kind of what people expect to happen from databases. So if you don't specify anything, everything's going to be unsynced, which means that nothing waits for anything else. You're going to get all your data as quickly as possible. But when you want to reason about joins between streams that should be synchronized, or if some data didn't arrive in one source and did arrive in another, these kinds of things are going to be kind of harder to work with in that scenario. I think the more important gotcha that I didn't mention yet is around what happens when you're replaying your data. So Upsolver associates the event time with the attempts to associate the event time with the time in the source system. So if I'm writing an unsynced job that loads data from external from Upsolver, so event times are always going to be associated with the current commit time. So the commit time and the event time are going to be the same when an unsynced job is writing data out. On the other hand, if I have a copy from job, so a job that's loading data from Kafka or S3 or something like that, and it's a sync job, then it's going to try to match the timestamps in the source. Now, in an ongoing fashion, so if the job was already up to date, and now I'm incrementally adding more and more data when it's already streaming live, then I don't have a lot of flexibility, because if you remember from the previous talk, the event time needs to be monotonically increasing. So if a minute ago I got a certain event time, I can't go down versus that. So if I discover some old files, I'm still going to have to force them into the event time that I'm processing now, because I can't go back in time in order to ensure that monotonicity. But when I create a new data source, so when I create a new copy from job that's loading data, for example, from Kafka, I have an opportunity to kind of backfill all of the data that already exists. So for example, maybe this Kafka is new and it doesn't have any data in it, in which case it'll start processing from now and it'll look pretty similar to an unsynced job. On the other hand, it might have data from 2 years ago. And Kafka stores a Kafka timestamp with the event. So you know for each record when it was produced, when it was created. And that time when it was created is often going to be important for joins, for example. So I might, for example, have two streams that I want to join, and data was emitted to them in real time, and there is a time component that would combine them. And definitely, like, if I load it now and it's like 10 terabytes of data and it'll all load in an hour, that's not the type of join I want. I want to join based on the time that it actually arrived in the source, similar to how I would have done if it was streaming. So in that case, Upsolver will backfill the event times from kind of the history that exists in the source when it's loading for the first time. So if we're taking it from Kafka, it'll fill in based on the Kafka timestamps. If it's taking from S3 or from cloud storage, then it'll either use the last modified of the files, or it'll use the folder structure. So if you specify a date pattern for the files, then it'll take the time from the date pattern of the files in order to backfill. So for example, if I have a kind of a standard format catalog where I have year equals 2021 / month equals 07 / day equals 5, then and you specify that in the date pattern, then the files in that folder will be associated with that date. And that way you can backfill, again, years of history or months of history or whatever it is. And it'll keep the graph, the time component, correct. And it'll allow you to do joins and all this stuff. Now, this was a big segue to say that when you create such a source, it's suddenly moving the event time back. So essentially, rather than this source, which is this copy from job, which mostly all of them are up to date, suddenly I have one that's 5 years delayed. And it's going to catch up quickly. It'll be doing its work. But in the meantime, since it's 5 years delayed, this could cause, depending on configuration, other jobs that depend on the same table that it's writing to wait for this data. But this is offline data. It's not something that I want to process immediately. And in fact, when a job runs, so let's say I have all these jobs that ran already, and they ran until 5 minutes ago. And now I start a historic replay, and it loads all of this data from 5 years ago. the jobs that would have consumed that data have already run. They're not going to run again. So I do have a guarantee that from now, again, depending how you configure it, but from now, it's going to wait and accept the data that arrives from that source. But all of the historic data isn't going to be processed in this job. So this is something that it's a double-edged sword. Maybe it's good because I don't want to process the historic data in my normal streaming flow. I want to do a separate flow. So I can create a new job that's just going to consume that data with filters on the source ID or things like that. But this is something to keep in mind, that when you run a replay, when you create a new copy from job writing into a table, this, if it's a sync job, it can cause a situation where jobs downstream are going to wait for it to catch up, even if it takes relatively long for it to catch up. So that, I think, is a relatively bigger gotcha. This is something that can happen often in production environments, and it's something to pay attention to. And then more importantly, or maybe equally important, is that the normal flow, the normal jobs that are all running that are synchronized, are not going to get the historic data. They're only going to get data from now. All the historic data is going to be ignored by these jobs. So again, this is often what you want. Often the synchronized jobs are, their intention is to be online and not backfill. But it's something to know that all this backfill data, you're probably going to want to do something with it, maybe create new jobs that read it or things like that. Now, if this historic backfill was unsynchronized, then all the data is going to basically be lumped into a few hours starting from now, depending how long it takes to load the data. So I'm going to read 50 gigabytes of data, put it into the first hour, another 50 gigabytes, put it in the second hour, et cetera, until I finish consuming the backlog. So in that case, all of my production ETLs are going to suddenly get a lot more data to process. So it's the exact opposite. So if the source is unsynced, then all the ETLs are going to consume all of the data from the source, regardless if they're synced or unsynced. And probably it means that they're going to be doing a lot more work, and potentially they're dealing with data that doesn't exactly fit. So you want to reason about this when you're doing a replay. So the reason this is especially critical during replays is that this is a situation where the event time of the source and the commit time are very, very different. So I'm kind of like loading data in that's 6 years old. So the commit time is now, and the data is from 6 years ago. In normal streaming situations, the event time and the commit time are usually quite similar. So it's not going to make a very big difference if it's like a few seconds earlier or later, except that you need to think about synchronization between streams. But here, it's a very big deal because the difference is big, and it means that either I'm going to be essentially handling all the data in some way, or not handling the data at all, or waiting for a bunch of data that I need to. So this is something that you need to think about, and it really depends on the use case, what you're trying to achieve with this historic backfill. If, for example, your pipeline is just, I have my source table, I do some enrichments that are unaware of the time, kind of like moving fields around, correcting some incorrect data, and writing it to a table, which I'm then going to be querying using Athena. If that's my use case, then I don't need the backfill to be synchronized, because in fact, I want my normal ETL process to go through all of that data and fill it in forwards. If, on the other hand, I have a join between two streams and the time component is critical, and I'm backfilling in order to join between two backfills, then I definitely want to make sure that everything is synchronized and make sure that my production pipeline is completely unaffected by this, or maybe there isn't even a production pipeline in this case, and I'm just building it now. And then I'll build a new pipeline on top of that once the data is ready, in order to do the join and for the join to be correct over all of the history. So it really depends on the use case, which one you want to use. Now, in general, in Upsolver, let's say, I mean, these are pretty advanced concepts in the end. It's like, it needs a lot of thinking about to like, what is my use case? In general, I would recommend to err on the side of using sync streams. So if everything is synced, your data correctness and observability is going to be much better. And there are some edge cases which you're going to need to think about, but generally they're not very offensive. So like, let's say in the worst case, when I have a problem with a sync stream, so it didn't process a certain amount of data, it's going to be very easy for me to find out which data wasn't processed because of metadata that we already that we expose. So it's not going to be hard to recover from that. Similarly, if it can cause streams to get stuck, so that's a big deal. But then if you drop the sync stream that you just added, they'll keep working. So the resolution is pretty simple, and you can always correct back. Whereas if you have all your streams unsynced, all of your data is going to lose the time connectivity immediately. So as soon as the data, every step that's unsynced reduces how connected the data is to its original time. And that's something that's a lot harder to reason about when you want to backtrack and see. I mean, you can do it, but it's just each step you need to think about again and again. Whereas with a sync stream, you really just have one timestamp, and that's just going to be the timestamp for all your tables, and that's super convenient. So losing that capability is it can often be a big deal, especially when you're developing and trying to kind of understand how hermetic your pipelines are and things like that. So generally, the recommendation is to have everything be a sync stream, a sync job, or a sync materialized view, and then selectively choose the ones that are going to be unsynced based on kind of the requirements. So generally, I would recommend to default to sync when you're not sure which one you should use. I mean, that being said, the worst case scenario is unsynced is just like how everywhere else in the world works. So you're not losing anything. It's just that you're not getting this really huge benefit of having everything synchronized.
If I am writing a pipeline that consists of multiple steps, right? Is the syncing versus unsyncing a choice that I'm making at each step, or is it a pipeline or job concept?
Yeah, so it's each step, each job. So so the technical difference between a sync job and an unsync job is that an unsync job is going to run on a window of commit times. So basically, everything that was committed in a certain window is going to be processed by that job, whereas a sync job is going to process everything that has an event time in its sources within a window. So one is saying the commit time has to lie between this time and this time, and the other says the event time has to lie between this time and this time. And in both cases, they guarantee completeness. So the sync job and the unsync job are both only going to run after all the source data was written to the sources. Just that with unsync jobs, since I'm relying on commit time and there's no such thing as backfilling commits, so I'm always going to run as soon as the time arrives that the job can run. Whereas with a sync job, it might be waiting because there might be slow processing upstream things. Now, in addition to that, so the first difference between again, now this is the technical difference. The first technical difference between a sync and unsync job is which data I process. One gives me a window of data based on commit time. One gives me a window of data based on event time. And in both cases, like the next job is going to do the same thing. So they're both going to cover all of the data, just in slightly different intervals, or very different depending on the on what the difference is between the two times. The second difference is that the output that I write. So I'm writing both a commit time and an event time for each record. So the commit time is always the commit time. It's when the record was committed. It's always going to kind of increase. It's always now. That's pretty simple to understand. And that's the same between a sync job and an unsync job. I commit the data, I get a commit time in my record, and it's when it was committed. The event time, when I'm running an unsync job, the event time that I write will always be equal to the commit time. So I'm writing commit time and event time, and they're the same. So that means that the unsync job, in fact, as I progress, if I have a chain of jobs one after the other, in each step of the way, the event time written for each event is going to increase, because this was committed, and then this is committed a few seconds after, this is committed a few seconds after. So each time I'm adding a bit more time, and each time the event time is progressing with the commit time. If it's a sync job, the event time I write is the same as the event time that I got. So the event time in the source is the same as the event time in the target. And this is true regardless if my source is a sync job, an unsync job. Like, it doesn't matter who wrote it, but just the event time, if it was an unsync job, is going to be equal to the commit time of my ingestion. So you can, in fact, synchronize a subtree of a ETL. You don't need to synchronize the whole thing. So for example, if I have a bunch of jobs that are unsynced in the beginning, and which get to a single table, and this table gets data, and the event time is equal to the commit time because everything's unsynced. And now I have a lot of jobs that are all synced and reading from the same table. Still, the event time is going to propagate in the same way to all of these targets. And I can join between them, and the joins will be consistent based on essentially a certain commit time of the first table where everything is synced on top of it. So that's kind of the technical difference between the two. And the kind of magic under the hood is that, in fact, sync jobs will only start running once all the data, they're guaranteed to get all the data that will be written to their sources. That's kind of the part that's complicated, that makes this all work.
That makes a lot of sense. So it's at the pipeline level, you're sort of just thinking about the logic of what you need in any given table or materialized view, and then if you sort of dig into this stepwise, you can say like this part of my ETL is unsynced, this part is synced, and basically the sync streams are going to guarantee the synchronization based on whatever the output of the unsynced part of the pipelines is.
Exactly. Yeah. Now, that being said, if you have unsynced and synced sections of your ETL, it does still become hard to reason about the timestamps. So you're probably better off to have everything synced, just because then you can very easily trace an event from the source to the target, because it's going to have the same event time throughout. And you can very easily find it in all the graphs and all the metrics. And if you want to replay, you can very easily find it as well and override it or whatever it is. So that's just very convenient. But I mean, again, depending on the use case, it might not always be possible. If, for example, like you have sources that are flaky, so you don't want to have those synchronized. So you might need to have unsynced, but at some point, you can always start from here, I'm synced, essentially.
Got it.
And then that's another important thing to mention, is that if I have a table that everyone writing to that table is unsynced, then the fact that I have synced jobs reading from it is great. So those jobs are going to synchronize between themselves, but they're not going to be waiting for anything, because any data written to the table gets an event time equal to the commit time. So I'm not losing. So if I have multiple unsynced sources writing to the same table, if one of them is flaky, it will not prevent sync jobs reading from that table from progressing. They just won't get the unsynced sources data. So that's that is a common use case, that you're going to have a table that is fed by one or more unsynced sources, which maybe some of your sources are synced and some aren't, even depending on if some of them are mission critical and some aren't, or things like that. And then from that point forward, from that kind of unsynced table, or a table that's fed just by unsynced jobs, you're going to have everything synced, because at least within that ETL flow, you want everything to be synchronized, even if you don't want to wait for errors upstream. If I have multiple sync jobs that are reading from the same table, then they are all going to be in lockstep, even if what's feeding into that table is unsynced jobs. So it could be that one of the sources is going to, I don't know, stop writing or crash or whatever, and it'll come back a few hours later and I'll have a burst of data. All synchronized jobs running on top of that table, in fact, all jobs, also unsynced jobs, will be in the same bucket, but then what they write isn't consistent, so it's hard to rely on that. But all of them are going to see the exact same version of events in that source table. So I can reason about, even though a source stopped running and then started running, I can still, having multiple sources that are synchronized reading from that same table, even though it's unsynchronized, I can make sure to join between them. But if I have two unsynced sources reading from the same table, then synchronizing between those two isn't possible. Or you're going to need to worry about differences in execution and things like that, regardless if the source is synced or unsynced, because each of these is going to progress separately at its own pace. So they're going to write kind of materially different information.
So it sounds like if you have sort of unsynced steps within your pipeline, that kind of puts the whole thing, it takes away the synchronization, right? And you can have synchronization and then following synchronization, but sort of in the middle, you're a little bit screwed up. But but what if I just want, so in the zip code example, right? So let's say that I have a sync stream pipeline that's like completely synchronized, but I need the one thing from this static place. That's not gonna screw up my whole sync pipeline, right?
No, because everything, so when a job is synced, so I can have the job that reads from the zip code be synced, so it'll be synced with its sources, but the materialized view is not synced. So the job is going to, the materialized view essentially is going to give me the latest state, whatever it is. And then when the job reads from it, I'm going to get I'm just going to get the latest state of that materialized view. So in that fashion, like I can set the materialized view itself that contains the zip codes to be unsynced. And then when the job that is synced, it'll be synced with its sources, but it won't be synced on the join, essentially. So in order for a join to be synchronized, so a join to synchronize the source and the joined tables, both the materialized view and the job need to be synced. So like, let's say the two main use cases for unsynced is when I have flaky sources, in which case I'm kind of saying, I'm going to take the hit and I'm going to forego synchronization, at least up until a certain point, because I don't want my entire ETL to stop working when a flaky source stops. That's one case. And the second case is that materialized views would often be unsynced when I don't care what state I get. I just want to get kind of the latest. I'm not trying to synchronize. I just want the state of the world in this materialized view at this time. So in that case, you'd have the materialized view itself be unsynced. Aside from those two places, and then with the case of replay, so sometimes a replay of data, old data loaded into a table, I'll want that to be unsynced, just because I want the ETLs to consume all that data, and I don't want it to make ETLs potentially stop processing until it catches up. So three cases. Aside from those three cases, I would generally say that you always want to do sync streams. It's starting to sound like a Monty Python sketch, but it ends with three for now.
No, you've convinced me that the default being sync streams, I think, makes a lot of sense. The second case that you sort of described, I really like the idea of, your pipeline is a sync stream, great. You have different use cases, fine. Just make materialized views into that pipeline based on, what you want, right? That's sort of how I envisioned it?
Yeah. That's exactly right. Yeah.
That's awesome. Well, thank you. Thank you for spending another 30 minutes with us. And I think this will be the final in this series, but I'm sure we'll have other topics that we'll want to, learn from you from. So we'll do more of these. Thank you so much, Yoni.
My pleasure. Thank you.